Okay, good day, future engineers. Now, let's padayon sa to ang next problem. So, up here, when designing a linear mass spring system, it is often a matter of choosing a spring constant such that the resulting natural frequency is a specified value. Suppose the mass of the system is 4 kilograms and the stiffness is 100 newton per meter. How much must the stiffness be changed in order to increase the natural frequency by 10%? So, tuod nung anong gakuan ta anong gasolve tagkuan natural frequency si purpose na mabala na to ang natural frequency. So again, no, the natural frequency mo na siya ang natural frequency so sa kabady. Mo na yung vibration or oscillation, natural nga oscillation. So ano naman sa may purpose ana. Now, di ba let's say na usa ka material, buta na to kana inyong ruler. Or let's say the spring na lang gid kay mamo gid to ang sample diri. Di ba if ang spring inyo ang ipatindog, let's say you have the spring na lugar inyo ng patindog. And then if inyo nang litikon or i-deflect or i-deform, i-deflect na siya ninyo, no? Something like this. So kana siya of course mo vibrate din na siya, di ba? So depende sa kadako sa inyo ang pag-deflect or deform. So pwede siya mo ana siya and then mo ani mo balik sa original shape or na po siya specific bagid nga musayop pagid siya og ayo. Now, ang natural frequency magadong nahitabo pag mag-apply ka og let's say force sa kabutang and then dili na mo yung natural frequency, iyang oscillations ana gagmay ra. But pag apply nimo sa force and then kato siya nga application nimo sa imo ang force nagmatch sa natural frequency sa body, mo dako ang iya ang oscillation. So mo na siya kung giingon last time di ba nga di ba kato sa kon pa lang yun first nga discussion on the hazards sa earthquake di ba katong siege di ba ingon atong giingon nga when the frequency the natural frequency of the body of the water body matches the frequency of seismic waves sa may tabo ni water body si water body nga still at first will oscillate mubalud so mo na siya so at kung maglinog gani siya niya si water body dili similar og frequency ni seismic waves dili wala gamay ra ang vibrations but when they are the same mo anam kadako ang oscillation so mo ni siya sa mga material sa mga butang or especially sa building gina try na to understand what is the natural frequency of that specific material aron malikaya na to nga ma-apply ang force na equal sa natural frequency sa butang because the more nga mo equal siya sa natural frequency sa butang of course musayo po siya appeal ang material therefore mas dako nga damage na hinuon ang mo resulta sa ato ang material so here we have an example this is a typical linear mass spring so mo ginato ang kuan ba example we have a mass and then we have a spring system tapos ingon niya suppose that a mass of the system so here we have a mass which is equal to 4 kilograms okay, so na natin value and then we have the stiffness K is equal to 100 Newton per meter. Yun siya nga, pila daw ang change sa stiffness to increase natural frequency by 10%. So you have an original natural frequency and then i-increase daw kuno nimo. So ang imo ang new nga natural frequency is that is 1.10 or 10% more than the original frequency. So, saan man nato na siya pag-solve? Very simple, no? Initially, of course, kuha na to ang frequency first. Ang initial frequency is equal to the square root of K over M, which is equal to the square root of 100 Newton per meter over 4 kilograms. So, initial frequency na to is just equal to 5 radians per seconds. Next, i-increase daw by 10%. So, our new frequency, so dapat na-increase na siya 10% with the original frequency. So, that is 1.10 times 5 radians per seconds. That is just equal to 5.5 radians per seconds. So, pagitan mo na itong stiffness K. So, patras na ta. So, the new natural frequency is equal to square root of K nu over mass. So, ganun K nu man because bako naman siya ng stiffness. And then the mass will just be the same. So, to solve or to get the K or the new stiffness, we just square the whole equation. That is equal to the new square of the new natural frequency is equal to K nu over m. Or the stiffness Kn is equal to mass times the square of the new natural frequency. That is just equal to 4 kilograms times 5.5 radians per seconds, or just 5.5 per seconds. Then our stiffness will become 121 kilograms per seconds. New stiffness. Or, I forgot now this is the square. So 4 kilograms times the 5.5 is equal to, yes, 1 to 1 kilograms per second squared. Mas sure nga kilograms per second squared mo na siya. Actually, no, pwede mo na ito mahimong Newton per meter. So, we have 1 to 1 kilograms per second squared. Then, mura na siya multiply of m over m. So, di ba m over m is just 1. And then, we know that kilogram meters per second squared is the Newton. So, that will become 1 to 1 Newton per meter. So, they are just the same. Then, but this is not yet the final answer. This is just the new stiffness. Yung gingon, how much must be changed in order to increase the natural frequency by 10%? So, the problem is the change of the stiffness. Pila daw ang rate. So, you have the new stiffness minus the original stiffness over the original stiffness. So, this is the ratio times 100%. So, that becomes, you have here a 1 to 1 minus 100 over 100 times 100%. So, there is a 21% increase. So, you need to increase the stiffness by 21% in order to obtain a natural frequency equal to 5.5 radians per second, which is 10% higher than the original frequency.